Good morning, students. We are doing chapter electrochemistry and till electrolysis and product obtained during electrolysis we had done. Conductivity in solutions, electrolytic cell, electrochemical cell, वो सब हमने कर लिया है. Now next. The next topic and the second last topic of the chapter is battery. What is battery actually? Cell. Battery or cell. क्या होता है battery? Any battery is a source of electrical energy, and battery is a galvanic cell. Means it is an electrochemical cell in which chemical energy is converted into electrical energy. Battery is having one or more than one cell connected in series. Maybe it has one cell or maybe two or three cells when connected in series. It is known as battery, and battery is used for getting electrical energy by the use of chemical energy. Now, in battery, there is a redox reaction taking place. That redox reaction is converted into electrical energy. The battery should be reasonably light. It should not be very heavy, or it should be compact, and its voltage should not vary appreciably during its use. Okay, when we are using this battery, its voltage should not be vary so much. Then it is known as a good battery. So good battery has following characteristics. It should be light, it should be compact, and voltage should not vary during its uses. There are two types of batteries, primary and secondary, or we can say there are two types of cells, primary cells and secondary cells. Now, what are primary and secondary cells? Student, primary batteries or primary cells are the cells which once used become dead and they cannot be recharged or they cannot be reused again. Such batteries are called primary batteries. जैसे हम लोग pencil cells use करते हैं in wall clocks or in remote and all. So they are primary batteries. Once they will be finished, they will be completed, they'll become dead. We cannot reuse again. They are known as primary cells या primary battery. Example of primary battery is dry cell, which is called Leclanche cell after the name of the scientist. And what is the use of dry cell? It is used in our transistors and clocks. जैसे मैंने आपको बोला ना, clock और transistor में इसको use करते हैं. Second type का जो example है of primary cell is mercury cell. Mercury cell we are using in hearing aids and watches, wrist watches we are using. And in wall clocks, we are using dry cell. So two examples in our book are given for this primary cell. One is dry cell, another one is mercury cell. We will discuss one by one. What is dry cell? See, this type of battery. देखा होगा आपने ऐसा cell. इसको dry cell बोलते हैं. What is its internal construction or internal working of this dry cell? See, this outer body of dry cell is made up of zinc. ये जो बाहर yellow part दिख रहा है, that is made up of zinc. This acts as anode. Oxidation takes place on this zinc. Now inside this battery, we'll have a graphite rod. This is called graphite rod. Here, this one is graphite rod. It is packed such that small portion of graphite is on the top, outside. This graphite, which is positive electrode, is a cathode, and the zinc rod is called, zinc container is known as anode. Now outside this graphite rod is surrounded by one electrolytic paste, which is made up of ammonium chloride and zinc chloride. The paste, electrolytic paste, is made up of ammonium chloride and zinc chloride. Dry powder न भरिए, paste बनावी न भरिए છે. નામ dry cell છે, કારણ કે paste नहीं बनाવીએ तो reaction नहीं થાય. Solutions માં reaction carry out થાય. એટલે electrolytic paste is made up of ZnCl2 and NH4Cl. उसके चारों तरफ कार्बन और मैंगनीज ऑक्साइड MnO2 का पाउडर स्प्रिंकल कर देते हैं. कार्बन एंड मैंगनीज डाइऑक्साइड MnO2 powder sprinkle around it. This is the construction of dry cell. Now As the zinc rod is anode, it is source of electron. So electron will move this way, and through copper wire they will flow and enter at the cathode. So from anode, electrons leave the cell, and from this cathode, which is a graphite rod, enter into it, and this bulb will glow. This way the cell is working. Now what are the reaction taking place in this cell? Again, the construction is, it consists of zinc container, which is anode. Cathode is graphite rod, which has powder of manganese dioxide and carbon, and space is filled by moist paste of ammonium chloride and zinc chloride. Now the reaction is, at anode oxidation takes place. Zinc will lose 2 electron and form Zn2+, and at cathode MnO2, manganese dioxide, in presence of ammonium ion, accept electron and form MnOH, and ammonia gas is released. Why this cell cannot be recharged? Because during its discharging, here in MnO2, oxidation state of Mn is +4, and when product is formed, the oxidation of Mn is +3. So during discharging, oxidation number of Mn changes from +4 to +3. But by reversing the direction of current, we cannot convert back +3 oxidation state to +4. That's why this cell cannot be recharged. જો પાછું તમે કરંટની ડિરેક્શન ચેન્જ કરીને આ +3 ને +4 ઓક્સિડેશનમાં ચેન્જ કરી દો તો એ સેલ રિચાર્જ થઈ શકે. But it's not possible to convert Mn+3 to Mn+4 because Mn+3 is a stable oxidation state. Why it is stable? That we will study in D block elements. Okay, that's why this cell cannot be recharged. Now this Zn2+, which is obtained at anode, combined with ammonia, which is released at cathode, and it form one complex Zn NH3 2+. This cell has potential of nearly 1.5 volt. So it is used to run small apparatus like in wall clock. They are used in transistors, in toy car, and in small instruments. This cell can be used. This is known as dry cell. Cathode ni reaction important છે boards માં આવે. And then what is anode and cathode and electrolyte and dry cell, that can be asked. Now the second cell, the second primary cell is mercury cell, जिसको हम button cell भी बोलते हैं. See this type of cell, maybe you have seen this in wrist watches, है ना, छोटे छोटे appliances में इसको use करते हैं. This is called mercury cell. Now which is cathode, which is anode, and how it works, this mercury cell. So mercury cell consists of zinc amalgam, zinc mercury amalgam as anode. Mixture of zinc and mercury is called amalgam. So it is called ZnHg amalgam, which is anode, and pasted off this mercuric oxide and carbon is known as cathode. Why it is called mercuric oxide? Because Hg has oxidation state +2. If it is in +1, then it is called mercurous. So anode is made up of zinc mercury amalgam, cathode is HgO and carbon, and electrolyte used is a paste of potassium hydroxide and zinc oxide. These may be asked in MCQs. Which of the following filled at anode in mercury cell? Which is cathode? Which is electrolyte? So it is KOH and zinc oxide. Now what are the reactions taking place? At anode, as we capped zinc amalgam in basic medium, because KOH is electrolyte. So in presence of OH minus, it loses electron and form zinc oxide. This is oxidation takes place at anode. And at cathode, HgO, because HgO is placed as cathode. So this mercuric oxide accept electron and convert it into mercury. These are the reactions taking place in cell. If we add these two reactions, the net redox reaction taking place is zinc mercury amalgam plus HgO gives ZnO and Hg. Now if we see this net overall reaction, it doesn't contain any ions. So this cell is long lived. It will not corroded when we keep it for a long time. जबकि ड्राई सेल जो हमने आगे पढ़ा था उसमें रिएक्शंस में आयंस इन्वॉल्व होते हैं, तो वो क्या करते हैं, आयंस सेल को कोरोड कर देते हैं. अगर काफी टाइम के लिए कोई ड्राई सेल पड़ा हुआ है तो उसके चारों तरफ पाउडर जमा हो जाता है, केमिकल जमा हो जाते हैं, बिकॉज आयनिक रिएक्शन कंटिन्यूअसली गोइंग ऑन. So mercury cell is comparatively better because in its overall reaction no ions are involved, complete molecules are there. This is having potential of 1.35 volt and remain constant, this potential, during its life. So that is the plus point. Its voltage does not vary, mercury cell. And as the redox reaction, yeah, solution do not contain any ions, as I told you, its life is long. So compared to dry cell, mercury cell is best. This is the diagram given. Diagram they will not ask. This is anode, this red part, and this is separator, yellow part, and blue part is cathode. And in between, electrolyte is filled. So this is known as mercury cell. Dry cell and mercury cell are primary cell. Now secondary cell or secondary battery. Primary cell किसको बोलते थे? The cell when used become dead and cannot be recharged or reused. But secondary cell, it can be reused or recharged by passing the current in opposite direction. जैसे अपन अपनी मोबाइल की बैटरी को रिचार्ज करते हैं, मोबाइल डिस्चार्ज हो जाता है तो हम वापस उसको रिचार्ज करते हैं, क्योंकि मोबाइल में जो बैटरी है वो कौन सी है? Secondary battery. So secondary cell or secondary battery is the cell which can be recharged again and again. Number of times it can be discharged or recharged. It is known as secondary cell. Two types of secondary cell we'll discuss here. One is lead storage battery, which is used in automobile. And inverters, lead storage battery. And second is nickel cadmium cell. एक और आती है lithium battery आती है, जो हम मोबाइल में यूज करते हैं. वो कॉस्टली भी होती है और it's very good. Its voltage is also very nice. Long live होता है and safe it is, lithium battery, but it is very costly. That's why it's not used so much. So common secondary cells are lead storage battery and nickel cadmium cells. We'll discuss them one by one. So what is difference between primary and secondary cell? Primary cell once dead cannot be reused, while secondary cells can be recharged or reused by passing the current in opposite direction. Now it is lead storage cell. आपने ऐसी बैटरी देखी होगी जो रेस कोर्स पे या कहीं पे ठेले वाले खड़े रहते हैं, अपनी लाइट लगाते हैं, उनके पास इस टाइप की बैटरी होती है ब्लैक कलर की. That is lead storage battery. What is this lead storage battery? It consists of anode and cathode. And this is anode because positive terminal se connected hai. This anode is made up of lead and positive plate, lead grills filled with PbO2. Negative plates filled with a spongy lead. એટલે આ જે anode છે, this is a spongy lead, while cathode is made up of lead coated with PbO2. lead oxide का coating ऊपर होता है. Clear? इसमें जो electrolyte filled होता है ये, that is concentrated sulfuric acid. और इसका concentration होता है 35% weight by weight. Okay? So this is the simple construction of lead storage cell. See, this is black battery. These are the long rods are there. Na? These are positive plate grilled with PbO2, and here it is negative plates, which is spongy lead, and in between them there is sulfuric acid filled here, which is act as electrolyte. यहाँ से पानी डालते हैं इसमें. ओपनिंग ऑफ एड वाटर. क्यों डालना पड़ता है पानी, वो मैं अभी आपको बताती हूँ. और यहाँ से आप उसको कनेक्ट कर सकते हो जो भी इंस्ट्रूमेंट आपको चलाना हो. So this chemical energy is converted into electrical energy. You have to draw this type of diagram when they ask in exam. This is anode, lead, cathode is lead coated with PbO2, and electrolyte is concentrated sulfuric acid. See, lead anode, grid of lead packed with PbO2 is cathode, 38% solution of sulfuric acid is used as electrolyte. Now when this battery is in use, what are the reaction taking place? See, Pb, which is anode, loses 2 electron and form Pb2+. But sulfuric acid is there, so Pb2+ combine with sulfuric acid and form PbSO4. So when we use this lead storage battery, as lead is converted into PbSO4, so after some time this PbSO4 will deposit on lead. Solid છે એટલે lead ઉપર deposit થતું રહેશે. 2 electrons will be lost. What's the reaction taking place at cathode? On cathode, PbO2 in presence of H+ ions, in presence of sulfuric acid, H+ and SO4 2-, accept electron and form PbSO4 and water. So on cathode also PbSO4 is deposited. As lead sulfate is sparingly soluble in water, So PbSO4 get deposited on anode and cathode. After some time, what will happen? The cell become, finished, dead, due to deposition of PbSO4 on anode and cathode. And second reason, see here, sulfuric acid is using, it is consuming in the reaction. H plus or SO4 2 minus means H2SO4 is consuming in the reaction, and water is produced in the reaction. So what will happen? If H2SO4 continuously consuming, water is continuously produced, then concentration of sulfuric acid will decrease, its density will decrease. So as density of sulfuric acid will decrease, the cell stop working or producing electric current. Now, how to recharge it? Pass the electric current in opposite direction. ज्यादा voltage का अगर current इसमें opposite direction में pass करेंगे, तो this cell become electrolytic cell and again it will be recharged. अभी जब ये discharge होता है तब किसकी तरह act करता है? जब ये discharge होगा तब it act as electrochemical cell. Chemicals are utilizing and we are getting electric current. When it will become completely discharged, we want to charge it again. Then what we have to do? We have to pass electric current in it so that again the chemicals will be regenerated. So when current is passed in opposite direction, again the chemical will be regenerated, means this PbSO4 will dissolve in the solution and reaction will taking place in the opposite direction. So overall reaction consisting of cathode and anode reaction is this one during discharging. Add kiya in dono reaction ko, anode cathode ko. So this is the reaction taking place in the cell when it is discharging. During charging, opposite direction the reaction will take place. On charging the battery, the reaction is reversed. PbSO4 and anode and cathode is converted into Pb and PbO2 respectively. So this cell is secondary cell because this can be recharged again. Its voltage is almost 2 volt. So many anode and many cathode when connected in series, its voltage can be increased. 12 volt की बैटरी बना सकते हैं, कार वगैरह में यूज होती है ना वो. इसका एक अगर आपने एनोड कैथोड यूज किया है तो इसका वोल्टेज होता है 2 वोल्ट. लेकिन सपोज अपन 4 एनोड और 4 कैथोड सीरीज में लगा दें तो इसका वोल्टेज हो जाएगा 8 वोल्ट. Even we can add 6 anode and 6 cathode in series, so its voltage can be increased by 12 volt. 12 volt की बैटरी अपन बना सकते हैं. This cell is called lead storage cell. But maybe 4 or 5 times if we charge or discharge it, then it will become useless, because we are using concentrated H2SO4 as electrolyte, and concentrated sulfuric acid is the strongest acid, so it will corrode the container, so we have to change the container and all. Otherwise this cell is good. This is known as lead storage cell. Second cell of this secondary cell is nickel cadmium cell. See this type of cell Panasonic का आता है. This is nickel cadmium battery, ऐसा लिखा होता है उसके ऊपर. How it works? It has longer life than this lead storage cell, but it is expensive. बहुत ज्यादा डिटेल में दिया नहीं है. इसका जो चार्जिंग और डिस्चार्जिंग रिएक्शन होता है उसमें से डिस्चार्जिंग रिएक्शन ये होता है. मतलब इसमें कैडमियम है वो एनोड है, बिकॉज कैडमियम का ऑक्सीडेशन हो रहा है, एंड निकल OH थ्राइस इज कैथोड क्योंकि उसका रिडक्शन हो रहा है. सो दैट्स ऑल फॉर दिस. और अगर इसके डिटेल में जाना चाहते हो आप, टेक्स्ट बुक में इतना ही है. For boards you can do this much only, but in detail see nickel cadmium battery is this is nickel cadmium battery. Cathode is made up of NiO&OH. Anode is made up of cadmium and some negative positive electrode. We have to connect it. So at the negative means at anode cadmium undergo oxidation and form CdOH twice, and at the positive electrode what is this? NiO bracket में लिखना है. So NiO undergo reduction and form NiOH twice. Overall reaction is this much. This is the reaction taking place in forward direction when it is charged, and backward direction when it will be discharged. जब आप इसको use करोगे तो backward direction reaction, जब आप इसको charge करोगे तो forward direction reaction होगा. Reaction is not important. Just remember which is anode and which is cathode in nickel cadmium battery. Now one important cell is fuel cell. What is this fuel cell? We know that in thermal power plants, so many matlab electricity generated. So many thermal power plants are there in India. what they are doing in that thermal power plant, how they are generating electricity. They are burning coal to produce steam. That steam is used to rotate the turbine, and with the help of turbine, they are generating electric current. So it is two-step process in thermal power plant. First, this chemical energy, that is heat of combustion of fossil fuel, is used for converting water into high pressure steam. भाई कोल है, पेट्रोल है, मतलब कोल है या कोई भी फॉसिल फ्यूल है, उसको जला के हम पानी को गर्म करके स्टीम बना रहे हैं, हाई प्रेशर स्टीम. And then we are using the high pressure steam to run the turbine to produce electricity. So in two steps, we are getting this electrical energy in thermal power plants. So one cell is constructed known as fuel cell, in which we can produce electric current in one step just by burning some fuels. So galvanic cell directly convert chemical energy into electrical energy, and it is highly efficient also. Such cells are known as this fuel cells. Galvanic cells में भी कई बार कैसा होता है कि continuously हमको reactant को fed करना पड़ता है. Then only the products will be formed and electricity will be generated. But some special galvanic cells are designed which converts combustion of fuel like hydrogen, methane, methanol, ethane, ethanol, and they'll be directly converted into electrical energy. They are known as fuel cell. So how fuel cells are better than this thermal power plants? So in thermal power plants, two-step process is there. What we call non-renewable sources we are using, fossil fuels and water and all. And efficiency is also very less. Only it is 36 or 40% efficient. While fuel cell directly combustion energy is converted into electrical energy in one step only, and it is efficient also. It is 70% efficient. So fuel cell is better compared to thermal power plant. See, this is the construction of fuel cell, alkaline fuel cell. Oxygen is added from this side. Hydrogen is added from this side. In between, sodium hydroxide solution is filled. See, this is NaOH solution, or we can use KOH solution. Now, it is simply burning of hydrogen in presence of oxygen. What's the reaction, overall reaction taking place? Hydrogen is combusted, oxygen support combustion, and by burning hydrogen in presence of oxygen, we are getting water molecules. See, पानी आई थी बाद में की वजह से, in the form of vapor. ये जो है यहाँ पे एनोड होता है, बहुत ही कॉस्टली होते हैं एनोड और कैथोड. एनोड जनरली प्लैटिनम पाउडर होता है, कैथोड प्लैटिनम और सिल्वर ऑक्साइड होता है. यूज नहीं होते, कैटालिस्ट कैन नॉट यूज्ड. सो सम एनोड और कैथोड जो है दे एक्ट एज कैटलिस्ट ओनली. इसके अंदर ही पोरस प्लेट्स होती हैं. इन पोरस प्लेट्स में एक्चुअली पाउडर फिल होता है, दैट इज प्लैटिनम पाउडर and platinum and silver oxide. So hydrogen is fed here, oxygen gas from this side. We have NaOH or KOH as an electrolyte in between. These are porous partitions. So water will be formed by combustion of hydrogen and oxygen, and that water will be removed from this side, and electricity is generated by the flow of current. See here, from anode, electrons move this side, this way, and this way the circuit is complete. Anode is a source of electrons, so यहाँ से इलेक्ट्रॉन निकलेंगे, यहाँ से इसमें से पास होके यहाँ से कैथोड से वापस अंदर आ जाएंगे. So this way, by the flow of electrons, electricity will be generated. This type of cell is known as fuel cell. इसको Bacon cell भी बोलते हैं, because hydrogen fuel cell भी बोलते हैं. This is cell formed by Bacon, the name of scientist. That's why it is also known as Bacon cell, fuel cell or Bacon cell. Okay. इसको हाइड्रोजन फ्यूल सेल भी बोलते हैं. अपोलो स्पेस प्रोग्राम में इसको लेके गए थे, स्पेस में लेके गए थे टू जनरेट इलेक्ट्रिक करंट. फिर और एक इसका फायदा है कि ये जो वाटर इसमें प्रोड्यूस होता है, एज आई टोल्ड यू कि इट इज a combustion of oxygen in presence of hydrogen only. So overall reaction is H2 plus O2 give H2O. This water obtained will be in gaseous state, and that is potable water, so it can be used for drinking purpose. तो अपोलो स्पेस प्रोग्राम में जब साइंटिस्ट इसको लेके गए थे, इस पानी को उन्होंने पीने के काम में लिया था. This cell is efficient also, around about 70%. As I told you, thermal power plants are only 30% efficient, 30 to 40, while these are 70% efficient. And there is no noise pollution, there is no air pollution while using this fuel cell. These are some of the advantages of fuel cell. Okay, now reactions you have to remember. See, catalyst भी लिखा हुआ है. Which catalyst used? finely divided platinum and palladium metal incorporated into electrode for increasing the rate of reaction. कहाँ है? सी मैंने बोला था ना, ये यहाँ पे बीच में, यहाँ पे ये जो ग्रे पोर्शन दिखाई दे रहा है जहाँ से इलेक्ट्रॉन फ्लो हो रहे हैं, दे आर कैटालिस्ट. Catalysts are used to increase the rate of electrode reaction. See, what is the reaction taking place at cathode? ऑक्सीजन डाला था हमने कैथोड पे, वो वाटर के प्रेजेंस में इलेक्ट्रॉन गेन करेगा, OH माइनस बनाएगा, और हाइड्रोजन lose electron and form water. So this is the reaction taking place at anode and cathode. If we add 2, this OH will be cancelled out, electrons will be cancelled out. It is simply 2H2 plus O2 give H2. So in fuel cell, the redox reaction is nothing but it is a combustion reaction of hydrogen. Now instead of hydrogen, we can also take methane. We can also use ethane. We can use methanol. Any organic compound we can burn in presence of oxygen. Then fuel cell is there. Okay. So what is fuel cell? Fuel cell converts chemical energy into electrical energy in one step. These are the advantages of fuel cell. First, तो मैंने जैसे बोला, it is more efficient compared to thermal power plants. Then in automobile, it is used. First, it is used in automobiles. Then it is pollution free. Neither noise pollution nor air pollution. उसमें तो क्या होता है, thermal plants में अपन coal burn करके water को heat करते हैं in order to prepare steam. So air pollution is there, noise pollution is there. बड़े बड़े turbine rotate होते हैं तो बहुत सारी आवाज होती है, इतनी आवाज होती है कि पास में खड़ा आदमी भी एक दूसरे की बात नहीं सुन सकता है. ऐसा इसमें कोई प्रॉब्लम नहीं है. No noise pollution, no air pollution. And water produced is used for drinking purpose. It is potable water. Okay. Now students, in next video we will do last topic of this chapter, that is corrosion and its chemistry. Okay.